Hello and welcome. You are watching a technical training video in a series of videos about solar-powered water system design, presented by the West and Central Africa Regional Solar Hub. Let's get started. If you haven't already, please check out our first 3 videos on the first 3 steps of solar-powered water system design. This video focuses in on step 4, pump selection. The purpose of a pump is to add energy to the water within a system in order to create flow. Pump selection is based on 2 things that were determined previously in step 3, the design flow rate and the system's total dynamic head, or TDH, associated with that design flow rate. So we'll select a submersible solar pump with those parameters, our design flow rate of 3.2 meters cubed per hour and our TDH of 54.5 meters. Now, to select a pump for our solar-powered water system, we will need to compare and examine various pump curves. Pump curves should be available from the pump manufacturer's website. For a Grundfos solar pump, specifically a submersible solar pump, we would look on the Grundfos SQ Flex product page and download the SQ Flex Renewable Energy-Based Water Supply Systems data booklet from the documentation tabs to view the available SQ Flex pump curves. Now, there's also a new line of SQ Flex pump curves that are rated to 2.5 kilowatts that are not shown in this data booklet but are available. So you can search for those products by searching on the Grundfos website and typing in the product name or product number, or just searching on Google for 2.5 kilowatt SQ Flex pumps. Looking here at our first SQ Flex pump curve, we see the 6 SQF-3. Now, this pump curve is a little unique because it's a solar pump curve. So on the y-axis, we have flow in meters cubed per hour, and on the x-axis, we have power in kilowatts. The blue lines shown on the pump curve and labeled 90, 110, 130, and so on are the TDH values. So to select our pump, we need to consider our design flow rate and see if it falls on this pump curve. Now, the range of this pump curve goes from 0 up to about 1 or 1.3 meters cubed per hour. So our design flow rate of 3.2 meters cubed per hour does not fall on this pump curve. Next, we'll look at the 11 SQF pump curve. 3.2 is still a little bit too high for this pump curve, just because it doesn't appear on the curve. Next, the 16 SQF-10. When looking on the y-axis at our pump curve, we do see that 3.2 appears. We can then also look at the blue lines showing TDH values between 30 and 70 meters. And so our TDH of 54.5 falls right in line. Next, we'll draw the line for our TDH right below 55 meters. And then we'll read over from 3.2 cubic meters per hour to that TDH line, and then read down to where it intersects the TDH line and see where it intersects the x-axis. In this case, it's about 1,100 watts, or 1.1 kilowatts. So the power required to operate at this design flow rate and TDH is 1,100 watts. You could find information on this pump, the 16 SQF-10, on the Grundfos website. This would show you the specifications for the pump, such as the product name, product number, also key electrical data, such as the DC rated voltage range of 30 to 300 volts, and also the rated current of 8.4 amps. These are important factors to consider when doing electrical design and solar design for this pump. So let's take a look at the solar powered water system design tool to see how we'd enter this information. Okay, now we've reached step 4 in our spreadsheet, the solar powered water system design tool. And we can see at the top that it's pulled some information from step 3, our design flow rate of 3.2 cubic meters per hour, and our total dynamic head of 54.5 meters. Now, these two pieces of information are what are needed in order to select a pump by looking at the pump curves from various manufacturers. In this case, we've narrowed in on a Grundfos pump, specifically a 16 SQF10 Grundfos pump, which is a direct DC powered pump. And we looked at the pump curves to see which one was the best and found that this pump model fit our system well. Then, looking at the specifications for this pump, we can see that the motor power at our design condition, that's the design flow rate and total dynamic head, was 1.1 kilowatts. Our minimum voltage input was 30 volts, the maximum voltage input was 300 volts, and our motor current draw is 8.4 amps. So that's the information required to enter on the spreadsheet for step 4. Thank you for watching this quick technical training video about solar-powered water system design presented by the West and Central Africa Regional Solar Hub. If you want to learn more or get assistance with the project you're working on, visit our website at wcarsolarhub.org. Thanks for watching.